So conjugate acid-base pairs have to do with the Bronsted-Lowry definition of acids and bases. The definition of a conjugate acid-base pair is a pair of compounds that differ by the presence of one H+, which is a proton. So the way you figure out a conjugate acid-base pair is you ask yourself the question, where did the H go? You're going to look at the reactants and products, and you're going to see what happened, where the H went when they went from reactants to products. The acid and base are always going to be the reactants. The conjugates are always going to be the products. So what you're going to do when you practice the problems is you're going to usually be given the whole equation, and it's going to ask you to label the acid, label the base, and then label the conjugate acid and the conjugate base. You're going to remember that the acid and base are always going to be reactants, and the conjugates are always going to be the products. So remember, what you got to figure out, what you got to ask yourself is, where did the H go? So when we look at number 1, I want you in particular to look at HCl, which is the reactant, and the Cl minus. So if you look at that, you can see that this H right here, this H in the compound, leaves at the end. There is no H there. Where did it go? We'll look at the NH3. What happened was the H went from the HCl, which left just the Cl ion, and it joined up with the NH3, which is what gave you NH4. You added an H. So remember, the acid is the one that loses the H. So that means that the HCl is the acid. The base is going to be the other reactant. It's going to be the one that accepted the H. And then as far as the conjugates go, remember, an acid has a conjugate base. Think opposite. A base has a conjugate acid. So the conjugate base is the one left over after the H left, which is the Cl minus, and the conjugate acid is what's left after the H has been added. So remember, where did the H go? That's the question you're going to ask yourself. So if we look at number 2, you have an HCN to start, but then you have a Ca minus at the end. So what happens is this H went over here to make water, H2O. So the HCN lost the H, so that is an acid. The OH minus is the other one, the base, or it gained the H. The elements or compounds left over after the H is gone is always going to be the conjugate base, kind of what's left over after the H leaves, which makes the H2O the conjugate acid. Okay, let's look at number 3. You have HNO3 here, and at the end you just have NO3. So the HNO3 is the one who lost the H, that's going to be the acid, which means the PO4 is going to be the base. And if you look, this H right here went and joined PO4. So that means the NO3 left over is going to be the conjugate base, and the HPO4 left over is the conjugate acid. Okay, and finally, number 4, you're going to have HCO3 and HCl. So what you're going to look at is right here, the HCl, and then here, just the Cl by itself. So again, this H went to HCO3. So the HCl would be the acid, the H plus donator. The HCO3 would be the base. The Cl, which is left over from the acid, would be the conjugate base. And the H2CO3 would be the conjugate acid.